To ring 3 doorbells simultaneously from a single button, there are a couple of methods to achieve this. Firstly, consider using a relay. For this approach, you'll need 3 doorbells, 3 transformers, 1 relay, 1 push button, and appropriate wiring. The steps are as follows. 1. Connect each doorbell to its own dedicated transformer. 2. Connect the push button to the control terminals of the relay. 3. Connect the output terminals of the relay to the common terminals of all 3 doorbells. 4. Connect the normally open terminals of all 3 doorbells to each other. The function of this setup is such that, when the push button is pressed, the relay closes, thereby connecting all 3 doorbells to their respective transformers. This action causes all the doorbells to ring at the same time. Secondly, you can explore the option of using a parallel transformer. This method requires 3 doorbells, 1 parallel transformer, 1 push button, and wiring. The steps for this method are as follows. 1. Connect all 3 doorbells in parallel to the single parallel transformer. 2. Connect the push button to the common terminals of the 3 doorbells. When the push button is pressed, current will flow through all 3 doorbells simultaneously because they are wired in parallel, and this will cause them to ring. Note that, regardless of which method you choose, several important considerations must be taken into account to ensure proper and safe operation. It is essential to ensure that all the transformers used have the same voltage and frequency output. This is critical for preventing damage to the doorbells or the transformers themselves, and for ensuring reliable performance. Also, select a transformer that is appropriately sized for the load, which in this case is the total number of doorbells connected to it. An undersized transformer will overheat and may fail, while an oversized transformer is unnecessary and wasteful. Securely connect all wires, ensuring that connections are tight and reliable. Loose connections can cause intermittent operation or even create a fire hazard due to arcing. Insulate all connections properly to prevent shorts or accidental contact with conductive parts. This is a basic safety precaution that is essential for any electrical work. Prior to putting the system into regular use, thoroughly test it to verify that it is functioning correctly. This will help identify any potential problems and prevent unexpected failures down the road. The 2008 National Electrical Code, NEC, provides guidelines and standards for electrical installations, and some of these may be relevant to your doorbell wiring project. However, it's crucial to consult the most current version of the NEC and any local electrical codes that may apply in your area. Chapter 3 of the NEC covers wiring methods and materials, and this is relevant to the type of wire you use and how you install it. Article 300.14 addresses the length of free conductors at outlets and switch points, which is important for making safe and reliable connections to the doorbells and the push button. Article 310.16 provides information on the allowable ampacities of insulated conductors, which is crucial for selecting the correct wire size for the doorbell circuit. If the transformers are located in a damp or wet location, Article 450.11 provides requirements for transformer installations to prevent electrical hazards. Chapter 7 of the NEC covers special conditions, and this might be relevant if your doorbell system includes any special features or is installed in a unique environment. Article 725.41 covers Class 2 and Class 3 remote control, signaling, and power-limited circuits, which may apply to your doorbell circuit if it is low voltage. Chapter 8 of the NEC covers communications systems, and while this might not be directly applicable to a basic doorbell system, it could be relevant if your doorbell is integrated with a home automation system. Article 800.24 covers the grounding of communications systems, which is important for preventing electrical interference and ensuring safety. When working with electricity, always exercise caution and follow safe work practices. To energize the circuit before making any connections or modifications. Use properly insulated tools and wear appropriate personal protective equipment. If you are not comfortable working with electricity, consult a qualified electrician to perform the installation. Electrical work can be dangerous, and it's always best to err on the side of safety. Understanding transformers involves several key concepts. A transformer is an electrical device that transfers electrical energy between two or more circuits through electromagnetic induction. It typically consists of two or more coils of wire, called windings, wound around a common core. The winding connected to the source of electrical energy is called the primary winding, while the winding connected to a load is called the secondary winding. Transformers operate on the principle of electromagnetic induction, which is the process by which a changing magnetic field induces a voltage in a nearby conductor. When an alternating current flows through the primary winding, it creates a fluctuating magnetic field around the core. This magnetic field induces a voltage in the secondary winding, which can then be used to power a load. The ratio of the number of turns in the primary winding to the number of turns in the secondary winding determines the voltage transformation ratio of the transformer. If the secondary winding has more turns than the primary winding, the transformer is called a step-up transformer, and the voltage on the secondary side will be higher than the voltage on the primary side. Conversely, if the secondary winding has fewer turns than the primary winding, the transformer is called a step-down transformer, and the voltage on the secondary side will be lower than the voltage on the primary side. Transformers are used in a wide variety of applications, including power distribution, voltage regulation, and signal isolation. They are an essential component of modern electrical systems. When choosing a transformer for a specific application, it is important to consider several factors, including the voltage transformation ratio, the power rating, the frequency, and the type of load. The voltage transformation ratio should be chosen to match the voltage requirements of the load. The power rating should be sufficient to handle the load current without overheating the transformer. The frequency should match the frequency of the power source. The type of load will affect the type of transformer that is needed. For example, a resistive load will require a different type of transformer than an inductive load. Understanding relays is also important for the first solution. A relay is an electrically operated switch that uses an electromagnetic coil to control a set of contacts. When a current flows through the coil, it creates a magnetic field that attracts a movable armature. The armature is connected to a set of contacts, which are either normally open, no, or normally closed, NC. When the armature is attracted to the coil, it moves the contacts, either closing the no contacts or opening the NC contacts. Relays are used in a wide variety of applications, including control circuits, protection circuits, and automation systems. They are an essential component of many electrical and electronic devices. Relays come in a variety of types, including electromechanical relays, solid-state relays, and reed relays. Electromechanical relays are the most common type of relay and use a physical coil and contacts to switch the circuit. Solid-state relays use semiconductor devices to switch the circuit and have no moving parts. Reed relays use a sealed glass tube containing a reed switch and a coil to switch the circuit. When choosing a relay for a specific application, it is important to consider several factors, including the coil voltage, the contact current rating, the contact voltage rating, and the type of load. The coil voltage should match the voltage of the control circuit. The contact current rating should be sufficient to handle the load current without overheating the relay. The contact voltage rating should be sufficient to handle the voltage of the load circuit. The type of load will affect the type of relay that is needed. For example, a resistive load will require a different type of relay than an inductive load. Wiring doorbells in parallel involves connecting the doorbells side by side so that the voltage across each doorbell is the same. This is in contrast to wiring them in series, where the voltage is divided among the doorbells. When wiring doorbells in parallel, it is important to ensure that the transformer is capable of supplying enough current to operate all of the doorbells simultaneously. If the transformer is not powerful enough, the doorbells may not ring properly. Also, it is important to use the correct gauge of wire to handle the current. The gauge of the wire is a measure of its thickness. Thicker wires can carry more current than thinner wires. If the wires are too thin, they may overheat and cause a fire. The NEC provides guidelines for selecting the correct wire size for different current ratings. Table 310.16 provides the allowable ampacities of insulated conductors based on their size and insulation type. For example, 14 American wire gauge (AUG) copper wire with THHN insulation has an ampacity of 15 amps at 90 degrees Celsius. It's important to consult the table for the specific wire type and temperature rating that you are using. Understanding voltage, current, and resistance is fundamental to electrical work. Voltage is the electrical potential difference between 2 points in a circuit. It is measured in volts. Current is the flow of electrical charge through a circuit. It is measured in amps. Resistance is the opposition to the flow of current in a circuit. It is measured in ohms. Ohm's law states the relationship between voltage, current, and resistance V equals I times R, where V is voltage, I is current, and R is resistance. This law can be used to calculate the voltage, current, or resistance in a circuit if the other two values are known. For example, if a circuit has a voltage of 12 volts and a resistance of 6 ohms, the current in the circuit will be 2 amps. Understanding these concepts is crucial for troubleshooting electrical circuits and ensuring safe operation. When working with electricity, it is important to use the proper tools and equipment. This includes insulated screwdrivers, wire strippers, pliers, and a multimeter. Insulated tools are designed to protect you from electrical shock. Wire strippers are used to remove the insulation from wires without damaging the conductor. Pliers are used to grip and manipulate wires. A multimeter is a versatile tool that can be used to measure voltage, current, and resistance. Always use caution when working with electricity and follow safe work practices. Remember to energize the circuit before making any connections or modifications. Wear appropriate personal protective equipment, such as safety glasses and gloves. If you are not comfortable working with electricity, consult a qualified electrician. The concepts outlined here provide a foundation for understanding how to wire 3 doorbells to ring simultaneously from a single button, whether through the use of a relay or a parallel transformer. Always prioritize safety and adherence to electrical codes when working with electrical systems.